Hi, scientist. I would like to read to you about how water evaporates. So, you completed your experiment on how water on different surfaces evaporates at different rates. So, I'd like to add more to your schema related to evaporation. Read along and track along. Header. Drying up. You know when something is wet, it is covered with water, or it has soaked up a lot of water. When it rains, everything outside gets wet. When you go swimming, you and your swimsuit get wet. Clothes are wet when they come out of the washer. A dog is wet after a bath. But things don't stay wet forever. Things get dry, often by themselves. An hour or two after the rain stops, porches, sidewalks, and plants are dry. After a break from swimming to eat lunch, you and your swimsuit are dry. After a few hours on the clothesline, clothes are dry. A dog is dry and fluffy after a short time. But where does the water go? That's been our big question. As you can see this photograph, you can see that I would infer that this is a photograph of the ocean. The caption reads, "You can't see water vapor in the sky." The water evaporates. There's that word. When water evaporates, it changes from water in its liquid form to water in its gas form. The gas form of water is called water vapor. The water vapor leaves the wet object and goes into the air. As the water evaporates, the wet object gets dry. What happens when you put a wet object in a scaled container? It stays wet. If you put your wet swimsuit in a plastic bag, it's still wet when you take it out of the bag. But why? A little bit of the water in your suit does evaporate, but it can't escape into the air. The water vapor has no place to go, so your suit is still wet when you get home. Have you ever seen water vapor in the air? Probably not. Water vapor is invisible. When water changes into vapor, it changes into individual water particles. Water particles are too small to see with your eyes. The water particles move into the air among the nitrogen and oxygen particles. When water becomes part of the air, it is no longer liquid water. It is a gas called, you got it, water vapor. So yesterday we completed the beginnings of a surface area experiment. So I'd like to read to you what two students completed. Julie and Art want to find out how surface area affects evaporation. They decide to do an experiment. They have some plastic boxes to put water in, some graph paper, and a set of measuring tools. They are ready to go. So you can see that they use different objects like we did. And this caption reads, "Julie has an idea for measuring the surface area of each box. She traces around each box on graph paper. She uses a meter tape to measure the distance between the lines on the graph paper. The lines are 1 centimeter apart." Wow, this looks so much like what we've been starting to work on in math, finding the area of a shape. The two students number the boxes. The box with the smallest surface area is number 1. The box with the biggest surface area is number 4. Then they measure 50 milliliters of water into each box. They placed the 4 boxes on the counter by the window. So you can take a look at the infographic. 1 week later, Julie and Art measured the amount of water in each box. Box 1 has 46 milliliters. Box 2 has 42 milliliters. Box 3 has 34 milliliters. And box 4 has 18 milliliters. Art thinks about the results. It seems that the surface area of the water in the boxes has an effect on the evaporation. But he isn't sure. Julie suggests organizing the results of the experiment. The students decide to do the following. Step 1, make a t-table to display the data. Step 2, make a graph of the data. Step 3, describe what they learned from the experiment. Can you help Julie and Art? Use the information they gathered to write a report about the effect of surface area on evaporation. Be sure to include the 3 kinds of information listed above. Think about the experiment. What additional information would be useful to better understand how surface area affects evaporation? So you will find your form after this reading in your Google Classroom. Thank you for reading along, and excellent job.